Welcome back to Time Pilgrimage, where the universe is our playground. Today, we've set our telescopes on the brightest stars in the night sky. To offer a perspective, let's discuss our Sun briefly. It's a G-type main-sequence star, but it's not among the brightest stars in the sky due to its relative distance from Earth. So, let's find out what stars outshine it when observed from our planet. We're embarking on a journey to explore the top 10 brightest stars in the universe. But before we jump into our list, let's talk about our very own star, the Sun. The Sun is a G-type main-sequence star and forms the cornerstone of our solar system. It has a diameter of approximately 1.4 million kilometers and is about 4.6 billion years old. Now, why is this important? As we dive into the list of the top 10 stars, you'll get a sense of just how small, young, or otherwise mundane our Sun is in comparison. Number 10, Beta Centauri. Located about 350 light-years away in the Centaurus constellation, this celestial marvel initially deceives us by appearing as a single star to the naked eye. However, powerful telescopes have revealed that Beta Centauri is actually an intricate triple star system, comprising two massive B-type giants in a close orbit and a third, more distant companion. But what does being a B-type giant signify? Well, these are massive stars that have used up the hydrogen at their cores and are now in a transitional phase, fusing helium and other heavier elements. The core temperatures of these stars are extremely high, allowing them to shine brightly, emitting a vibrant blue-white light. Their luminosity is thousands of times greater than our Sun, making them easily visible from Earth despite their great distance. The composition of Beta Centauri primarily involves hydrogen and helium, like most stars, but spectral analysis has also revealed the presence of trace amounts of heavier elements like silicon and magnesium. These elements are forged in the cores of massive stars, a testament to the extreme conditions under which these titans operate. Beta Centauri's dual giants are so close that their outer atmospheres nearly overlap, a phenomenon that allows astronomers to study tidal interactions between massive stars. Understanding these interactions could shed light on the life cycles of massive star systems, potentially helping us understand other cosmic phenomena like supernovae and even black holes. To sum up, Beta Centauri is not just a point of light in the sky, it's a dynamic, complex system of massive stars that challenges our understanding of stellar evolution. Number 9, Acar. Our celestial journey takes us to the brilliant Acar, the 9th brightest star gracing our night sky. Situated approximately 139 light-years away in the constellation of Eridanus, this star has a fascinating story written not just in its luminosity but in its physical characteristics. To begin with, Acar isn't your typical spherical star, it is one of the flattest stars ever observed. But why is it so? Well, the rapid rotation of Acar, spinning at velocities of up to 250 km per second, results in a centrifugal force that flattens its poles and bulges out its equator. This rapid rotation lends it a unique oblate spheroid shape. Yes, this star is literally spinning itself into a flattened shape. This solitary star has used up most of its core hydrogen and is in a transitional phase, fusing helium into heavier elements. Its outer envelope is extraordinarily hot, with temperatures reaching around 20,000 Kelvin, which gives it that striking blue color when observed from Earth. This intricate mix of elements makes Acar a fascinating subject for astronomers looking to understand the life cycle of massive stars. Number 8, Procyon. Situated a mere 11.46 light-years away in the constellation Canis Minor, Procyon is practically a neighbor in astronomical terms. Procyon is not a solitary star but a binary star system. This stellar main component is accompanied by Procyon b, a faint white dwarf that was once a mighty star but has now exhausted its nuclear fuel and contracted into a dense, Earth-sized remnant. When it comes to composition, Procyon A is predominantly made of hydrogen and helium, which are the building blocks for most stars. These elements, forged in the intense heat and pressure at the star's core, give astronomers invaluable clues into the nuclear fusion processes taking place within. While its outer layers are helium, its core is predominantly carbon and oxygen, which is typical for white dwarfs. Procyon shines with a brightness that's about 7 times that of the Sun. That might not seem like much compared to some of the other stars on our list, but it's Procyon's proximity to Earth that makes it stand out. Number 7, Rigel. As we continue our celestial tour, we arrive at the dazzling Rigel, which shines as the 7th brightest star in our night sky. Located around 860 light-years away, this luminary graces the constellation Orion, marking the hunter's left foot. But Rigel is far more than just a point in Orion's stellar anatomy, it's a complex multi-star system that's a treasure trove for astronomers and sky gazers alike. To begin with, Rigel is primarily a blue supergiant, specifically a B-type supergiant. Now, what does this mean? In stellar terms, supergiants like Rigel are among the most massive and luminous stars in the universe. They are burning their nuclear fuel at an extremely high rate, leading to their enormous size and brightness. In Rigel's case, this supergiant has a luminosity about 120,000 times that of our Sun. Rigel is actually part of a star system comprising at least 4 stars. The primary star, Rigel A, is the one we see most clearly and is itself a binary, accompanied by a fainter companion. Being a massive star, it is destined for a spectacular demise in the form of a supernova. While this event won't happen for thousands, or even millions, of years, it will be an incredible phenomenon that will provide invaluable data on the life cycles of massive stars. Number 6 Capella. Next up, shining as the 6th brightest star in our sky, we encounter Capella, a celestial beacon situated in the constellation of Vega, the Charioteer. Located at a close distance of about 42.8 light-years from Earth, Capella might seem like a singularly bright point in the sky, but it's far more complicated and intriguing than it appears. The G-type giants are particularly interesting because they're quite similar to our Sun but have evolved further, exiting the main sequence phase of their life cycles to become giants. They are so close to each other that their outer atmospheres are almost touching, making them an incredibly intriguing binary system to study. The red dwarfs in the system, while less luminous, are equally captivating. Composed mainly of hydrogen and helium, they represent a more primitive stage in stellar evolution. As for luminosity, the 2 G-type giants alone are about 80 times more luminous than our Sun. Number 5 Vega. Positioned at a relatively close 25 light-years away, our next celestial luminary is Vega, the shimmering eye of the constellation Lyra. Renowned for its brightness and its role in many cultural mythologies, Vega is far more than just another twinkling star. It is a cornerstone in the field of astrophysics and a guiding light for both sailors and astronomers alike. Firstly, Vega is an A-type main-sequence star, meaning it's in the prime of its life, fusing hydrogen into helium in its core. While it's roughly the same age as our Sun, about 455 million years old, it's more than twice as massive and has an estimated 40 times the Sun's luminosity. Like many other stars on our list, Vega is primarily made up of hydrogen and helium, the most basic elements in the universe. However, its atmosphere contains small traces of heavier elements like carbon, oxygen, and even metals such as magnesium and iron. These elements are essential in understanding the stellar nucleosynthesis processes that occur in stars, helping astronomers map out the life cycles of celestial bodies like Vega. Vega is spinning at a staggering speed of about 236 km per second at its equator, so fast that it completes a full rotation in just a little over half a day. This incredible rotation flattens Vega at its poles and bulges it at the equator, making it oblate. The speed also affects its surface temperature, making the poles hotter than the equator, a fascinating anomaly in stellar physics. It's so consistently bright that it served as the northern pole star about 14,000 years ago and will regain that status in another 12,000 years due to Earth's axial precession. Number 4 Arcturus. Arcturus, its name itself, derived from the Greek words for guardian of the bear, pays homage to its close celestial relationship with the constellations of Ursa Major and Ursa Minor. At its core, Arcturus is a red giant star, signifying that it has exited the main sequence phase of its life cycle and is now in the twilight of its existence. With an age of approximately 7.1 billion years, it is one of the older stars in our vicinity. The star has expanded to around 25 times the diameter of our Sun, and its outer layers have cooled down, giving it its distinctive orange-red hue. Predominantly made of hydrogen and helium, like most stars, Arcturus has also begun the process of fusing helium into carbon and oxygen in its core. These not only attest to its advanced age but also make it an interesting subject for studies on stellar evolution and nucleosynthesis. In terms of luminosity, Arcturus is an absolute powerhouse. Moreover, Arcturus has a high proper motion, meaning it's rapidly moving across the celestial sphere relative to other stars. In summation, Arcturus is not just another bright star, it's a celestial storybook, recounting tales of cosmic evolution, galactic dynamics, and the intricacies of stellar physics. Number 3 Rigel Centaurus. As we ascend the luminosity ladder, we arrive at an exceptional celestial system that bears the distinct honor of being our closest known stellar neighbor, Rigel Centaurus, or Alpha Centauri. Situated at a mere 4.37 light-years away, this system is a cornerstone of both scientific research and popular imagination, often cited in discussions about interstellar travel. But what makes Alpha Centauri worthy of such attention, and why does it secure the third brightest position in our star-studded list? At its core, Alpha Centauri is a triple star system comprising two Sun-like stars, Alpha Centauri A and Alpha Centauri B, and a faint red dwarf known as Proxima Centauri. The A and B components form a close binary system, locked in a dance that takes about 80 years to complete one orbit. Meanwhile, Proxima Centauri orbits these two at a considerably greater distance and, as of my last update in January 2022, holds the title of the closest known exoplanetary system to Earth. The primary star, Alpha Centauri A, is a G-type main-sequence star, not dissimilar to our Sun. It's about 1.1 times the mass of the Sun and approximately 1.5 times as luminous. Its companion, Alpha Centauri B, is slightly smaller and less luminous, being a K-type main-sequence star. Their comparable sizes and compositions, predominantly hydrogen and helium with traces of heavier elements, make them the subjects of intense scientific scrutiny as possible hosts for life-bearing planets. And then there's Proxima Centauri, a red dwarf with a mass about 1/8 that of the Sun. Though not visible to the naked eye, it holds enormous significance due to its proximity and the confirmed presence of exoplanets orbiting it. Even with its low luminosity, its closeness makes it an appealing target for future interstellar exploration. In terms of sheer luminosity, the combined light of Alpha Centauri's components makes it one of the brightest objects in our night sky. However, most of its luminosity comes from Alpha Centauri A and B, making it an overwhelming beacon when viewed from Earth and neighboring star systems. Number 2, Canopus. Venturing further on our celestial journey, we come across a dazzling beacon that has guided navigators and intrigued astronomers for millennia. Ladies and gentlemen, allow me to introduce Canopus, the second brightest star in the night sky. Situated in the constellation Carina, Canopus lies approximately 310 light-years away from Earth. Its name has roots in Greek mythology, where Canopus was a navigator for King Menelaus of Sparta. Yet, the significance of this star transcends mythological tales to encompass groundbreaking roles in both historical and modern navigation, as well as in astronomical research. Firstly, let's delve into the fundamental characteristics that define Canopus. It's classified as an F-type bright giant, a category of stars that have exhausted their core hydrogen and are in the process of evolving into more complex stages. With a mass about 8 times that of our Sun and a diameter 71 times greater, Canopus is an absolute colossus in stellar terms. Yet, despite its enormity, it's a young star, with an estimated age of 30 to 40 million years. Like most stars, it's chiefly composed of hydrogen and helium, but what sets it apart are its metallicity levels. Studies have revealed an abundance of elements like carbon, nitrogen, and oxygen, as well as heavier metals like iron and magnesium. In terms of luminosity, Canopus is a veritable powerhouse, shining with the luminance of approximately 10,700 suns. This incredible brightness makes it an indispensable tool in the field of astrometry, the measurement of celestial positions and movements. Canopus has been used in satellite orientation, and its brightness serves as a calibration source for space telescopes, including the Hubble. Adding to its modern-day utility, the star's extreme brightness makes it visible even from low latitudes, providing a reliable point of reference for early explorers navigating the southern seas, as well as for pilots and astronauts in more recent times. In fact, its role in navigation was so well regarded that Canopus served as the namesake for the Apollo lunar module's guidance computer, known as the Canopus Star Tracker. To encapsulate, Canopus is not just another bright star in our sky, it is a celestial phenomenon with multifaceted implications for science, history, and culture. Number 1, Sirius. As we culminate our journey through the illustrious echelons of celestial luminosity, we arrive at the crowning gem of the night sky, Sirius, often referred to as the dog star owing to its placement in the constellation Canis Major. Dominating the heavens with unparalleled brightness, Sirius has enchanted observers for thousands of years, serving roles in various cultural mythologies and becoming an essential component in modern astrophysical research. But what factors contribute to Sirius's unrivaled brilliance, and why does it so aptly deserve the title of the brightest star in our observable universe? First, let's unravel the fundamental characteristics that define this cosmic masterpiece. Sirius is actually a binary star system, consisting of a main sequence star, Sirius A, and a faint white dwarf companion, Sirius B. Sirius A is about twice as massive as our Sun and approximately 25 times more luminous. It belongs to the spectral class A1b, indicating it is hotter and younger than our Sun, with an estimated age of only 120 to 150 million years. When it comes to its composition, Sirius A is primarily composed of hydrogen and helium, much like our Sun. Sirius B, the white dwarf, holds its own set of mysteries. It is the size of Earth but contains almost the mass of our Sun. The incredible density and gravitational forces at play in this compact star make it a fascinating subject for the study of stellar evolution and the end states of stars like our own Sun. In terms of sheer luminosity, Sirius outshines every other star in our night sky. Its apparent magnitude stands at a staggering -1.46, making it almost twice as bright as Canopus, the second brightest star. Much of its luminosity is a result of its proximity to Earth, lying at just 8.6 light-years. If you enjoy this cosmic countdown, please remember to subscribe, and hit that like button and give us your comments as to what kind of video would you like to see next.